Hello, good morning. Thank you so much for joining me in my shop here today on September 24th. Another sunny day here. Oh my gosh, we're getting day after day of sunshine, and the temperature is only getting up to around 22 degrees, which is quite cool. It's really beautiful fall weather. That's what I could call it. So here we are, day 3 on this radio. Yesterday I worked on the power supply, filter capacitors, and a resistor in that peculiar, maybe not peculiar, but that special type of resistor that's mounted on the back of the radio. You know, this raises an interesting question. I kind of raised it yesterday when I mentioned about a chain. If you break a chain, you only break one link. How come this has had 2 sections replaced? So I pondered this question. How could this be? Well, there's a couple, there's probably 50 different ways this could be. What about this particular radio? What has happened here? Maybe all that happened to this resistor is this contact came free from the resistor. Now, I don't know how possible that is. I've never torn one of these apart to look inside it. I don't really know how these contacts are made onto the resistive element. I'm not even sure what the resistive element is. I think it's a wire, but I'm not even sure what's inside here, inside any of these. So what if that's the case? What if all that happened was this contact came free, and that led the previous guy to discover the defective resistors in here, but they really weren't in here. They were just this contact. That would explain why 2 of these would be replaced. Is that really the case? That would mean the resistor in behind here is continuous all the way through, just as it always was, and now these have been paralleled in, and that has dropped the overall resistance of this circuit enormously. What would that do? So we have a big resistor here, we have a medium resistor here, and some smaller ones. Smaller ones probably don't count. Most of the voltage is dropping on the big one and this one. So the ratio between here and here is really what is setting up the voltages, voltage for this point in particular. So I think it makes perfect sense at this point to take a voltage check and see what the voltage is here. I mean, the radio did operate, so they can't be totally out of whack. It could be that you could alter the values of the resistances in here, but maintain the same ratio and get the same voltage drop, and thereby read the appropriate voltages. Meanwhile, the amount of current flowing through here is actually much higher than intended. Is that what's really happening here? I doubt it very much. But, how do you know? How do you know any of these things? How do you even know what you need to know? Boy, oh boy. Okay, we can get into a lot of semantics here, but... Well, let's see. So if this contact is out, this one would still be in. So if I read from here to here, I'm either reading straight through these 2 capacitors, or resistors, or I'm reading these 2 in parallel with the thing inside there. I get very, very different readings if that were the case. Can't remember the value of these resistors. Let's just do them section by section first. Okay, so this says 3500 and it reads 33. This was, I can't remember what it was. Was it 15? I can't remember. And I put it in so you can't read the words, of course. I don't like rotating these too much. 20. There should be 20. Now, I mean, it's in a circuit. So if it was in parallel with 20 inside the resistor there, we would get 10 or less here. Pretty convincing. Let's go across them all now. This is the big test. The big test. So that looks like the addition of the two external resistors and the internal one is not playing a role. Whatever's going on in here is not going on. Okay, I think that's the case. Let's take some voltage measurements. I got to figure out what the voltages should be. I'm going to study the schematic on my own here and see if I can't locate where there is voltage information. I just need to kind of transfer it to here. Good. Does that make sense? I think so. Kind of funny how long you can stare at something before you finally see what you need to see. Let's zoom in on this voltage chart here. And I was all excited about these voltage readings out here on it, and then I go, oh look, right on the resistor they've written the different voltages there. 600 kilocycle series trimmer on, that's something else. Okay, so that's what we should read, and I'm pretty sure these are all to the chassis, relative to the chassis. It doesn't say anywhere I can find, but I'd be surprised if that's not the case, especially this minus one. The only way you can get this minus one is this guy here. This is the unconnected terminal right here. 0 volts. Not connected to anything. That's a little weird. Okay, so I have the voltages. We can make the tests. Great. I can do all these, in fact. 340. Okay. I put 400 volt capacitors into this radio, so I'm sure they're fine. Okay, let's take these measurements. Let's take a bunch of these measurements and see what's going on. Okay, so I'm going to be using this meter here to make the measurements. We can switch on the radio here. There we go. This guy is currently set to 500 volts because we're going to go after the big voltage. We're going to find it right up here. And so 500 volts, and this is supposed to be what did I say? Just a sec while I get this up on my own screen here. 235 volts. So 500 volts, 235 is just shy of straight up, right in here. Okay, we're supplying the full Monty here. Maybe not have an antenna. Okay, that's just perfect. We are ready. 111 volts. It's just a little low, but not so low it should matter. What do we got? 235 exactly. That's fantastic. The next one should be 155. Okay, so 155. This is the 150 volt scale, so 155 is just off scale. Perfect. It's perfect. Okay. Now this one's supposed to be 0. Sure looks like it. 5 volts full scale. There must be some other way that this is tied to the chassis. This piece here. Because how could that be otherwise? Then this should be minus. What did it say? It said minus 16 volts. Okay, so this is a 15 volt scale. Should go right over. Perfect. It's perfect. So okay, we won this battle. Now the negative voltage here is applied to the grid of the output tube. I think it's on the other side of this. Must be on the other side of this. No, there's a wire. What tube is that? That is the output tube there, right there. Well, let's take a look here. Might hear this on the speaker. Yeah. So just about all of it. All 16 volts. 16 volts. It's a 6F6. This has to be the right bias voltage, but let's take a look just for fun. We'll look in the book. EF6, 6F6. Right here. Power pentode. So grid number 1 control voltage minus 16.5 for fixed bias. If you have a 250 volt, a volt on the plate, 16.5. If you had a little more voltage on the plate, a little more bias, minus 20. It's right on the money. It's right on. So that also eliminates another concern that we should all have with these radios, and that is the output tube is not biased properly. That can easily occur in a radio that's using cathode biasing for the output tube. This one doesn't. This one is using the power supply trick to generate a relatively negative voltage and use that, a fixed bias voltage. Good. That's good. Wow, what am I going to do? I thought I might be working on some of those problems. Maybe there's a couple hairy wires in here I should really deal with before disaster strikes. And I'm looking at this one right here, right at the end of my finger, where the insulation is knocked off it completely. It's not a common thing for me to replace wires in a radio. I've managed to avoid that. Look at this one, it's all cracked here too, this black one. Maybe I shouldn't touch it. Goes up here. It looks like it's just airbornely connected to this capacitor, which is that's coming in from right from the antenna terminal, right here. See, an antenna terminal wire, capacitor, and then a wire all the way down to here, where it takes a dive. Right in the bend here, the insulation is gone. You know what, I'm going to try to avoid replacing any wires in this thing, because I think as soon as I start doing one, they're all going to fall apart. And again, as long as they're not in contact, the insulation is superfluous. Would that be the right word? Superfluous insulation. Well, the next issue for a radio like this really starts focusing in on bad capacitors and the like. So we have a large 0.1 here. If you notice, it's kind of in the floppy state or the hanging state. I think this was replaced by the last guy who worked on this radio. So a newer 0.1, and maybe it's in good shape, maybe not. Big capacitors doing a big job. I also have this guy. Why? Look at this. Okay, I've noticed something here. This capacitor, the outside of it has become shiny. I can't really show it in the camera. But see, these ones are dull. This one's becoming shiny. I know what I'm going to do. We're going to do a heat run check. And I have the feeling that this is overheating. This would be the second time, only the second time, the hundreds of radios I've fixed, where I found a capacitor actually starting to fry up. It's connected right to the B plus high voltage. So let's get out the thermal gun here. I may have good show. It's all here. The batteries here and everything. Excellent. So I run around my house with this thing quite regularly, looking at stuff. This thermal viewer. There we go. What's making a noise here? Ooh, it's sizzling. It's a sizzler. It's sizzling bad. Oh my gosh, look at, see that red? So part of that is this resistor, the other part is this capacitor is frying. It's frying up right in front of me. Look at it now, can you tell? That's the power being turned off, because something bad's going to happen if we leave this in here. Really, that's only the second time I found a frying capacitor. Let me look at it with the close-up camera. You really, get the thrill of this situation here. It's really, she's just all liquidy. Wow. How hot is it? Well, we can figure that out. We can find that out by using that thermal viewer. How hot did it get? Okay, so the way this thermal viewer works, I mean, it's all red here because the The lens is so close to the capacitor. The temperature is 75 degrees C. The highest temperature in the field here is about 80 degrees C. 80 degrees will hurt you. You don't want to touch 80 degrees with your finger, not for long, that's for sure. I personally, when things get around 50 degrees, and it depends if it's metal or not, because metal will transfer heat much faster, give you a much higher temperature when you touch it. Around 50 degrees, I can't touch things any longer. I can't keep my finger on them. And, yeah. Okay, well, we know what we got to do next. We got to get rid of this capacitor here. This is a very, very bad actor. This, you know, if this were to short out, it's right on the high voltage here. Oh, it looks like there's a big drip of wax just pouring out here. Let's, I don't want, here, enjoy the thrill. The thrill. Look at that big hunk of wax just pouring out and heading south. So, you know, you can get a radio like this, it's been sitting around for a while, but it did this thing 20 years ago, and that piece of wax is sitting right there. You can spot the wax and figure out maybe what has happened without even plugging it in. Okay, you got to come out. You got to come out of there, because you can't stay. So here it's attached right to this ground terminal, which is soldered right to the chassis. So this thing had the entire 235 volts across it. I need to get wax all over my fingers. I don't want to get wax on my fingers. I've got wax on my fingers. Okay, here we go. Nip this guy here. What am I doing with these big ones? Big capacitor needed big cutters. Wow. Funny I didn't notice this earlier. Could it be it was fine right up until now? That's very unlikely. Would something like this build up pressure and explode? I don't think so. It's not hermetically sealed to that degree. Could something like this pop? Oh yes. Oh yes it could. This thing could get so hot, just my imagination saying this now, but I've seen one capacitor do this. This thing can get so hot that it's ready to vaporize or steam off all the moisture that's in here, like it's doing on the surface. And then it can short out, and that electric current can generate enough extra heat to cause enough steam to cause a steam explosion. And I've seen this with a small capacitor in a more modern piece of equipment. Capacitor more like this size but smaller yet. And I could see the shell, empty shell, still connected. And the other end of it was blown right off. All the guts were missing. It's just an empty shell. And on the other side of the device, this isn't turned on, is it? No. The other side of the device, there was paper mache blown into all the parts over here. So in this other device, more modern device, when that capacitor let go, it must have sounded like a shotgun going off. So could this do the same? Well, we didn't find out, and I think that's a good thing. Now, what size is this guy? What size is he? Am I going to be able to read any of that? We're going to find this on the schematic. Or is this an add-in? Was this added in? That's a good question. Is this an add-in? Well, let's look on the schematic. If it's an add-in, it won't be on the schematic. What do you do with a drippy capacitor? You throw it right in the garbage. That's where it goes. Okay, let's look at the schematic here so we can find out. Okay. Let's look at the parts. The parts diagram here will show us that part if it exists. So here it is. There it is. 25 microfarads right there. That's the one right there. He's there. 25. Looks like it says 0.25 microfarads. Let's not be fooled now. So I'm looking back in the radio. Is there another capacitor in there? I don't see one. Only this big guy. So you see, look over here. This is a 0.1. You see the size? This is a 0.25. Did a guy load this thing up with a whole bunch of electrolytic capacitors as he replaced a bunch of non-electrolytic capacitors? Is that what's happened in this radio? Because there's electrolytic capacitors all over the place. Now, they really aren't in this radio. The electrolytic capacitors are these tall tubes here, these guys. So it could be they're not picturing any other electrolytic capacitors. They're picturing the mica ones as square blocks. They're picturing them as they look. They are picturing them as they look. Okay, so I'm looking at this capacitor. This is a very important one. You notice this piece here? This is a metal bracket coming out and wrapping right around this capacitor. Because this capacitor is, and this circuit is very sensitive to picking up any extraneous noise, hums or stuff like that. So they've shielded the capacitor very carefully with a metal bracket. Well, that is still in the radio. The original capacitor's in there. And over here is another one that looks original, 0.007. And it looks to me like an electrolytic capacitor again. There was no way a 0.007 is electrolytic. So what's going on here? Let's look at these. I'll show you these because they're of interest. This is of great interest here, or some interest. And what we're trying to do is calibrate the dimension here. Because I really think this is a 0.25, not the monster that was there. Now, maybe the guy added, he didn't add it. Why would he would cut this out? He'd cut out an old wax one and stick in his new piece of junk that eventually flamed out. We're going to have to find out the size of the one that was in here. And we're going to have to figure out what's going on up here. Okay, let's go back, look at the radio. Yeah, like, somebody has done stuff in here, and we just don't know for sure what. Let's look at the volume control. Here's the volume control. Here's the metal-clad capacitor. The metal bracket is soldered right down to the chassis here. It's not just riveted. It's been soldered. Sitting right here, the capacitor is tucked inside. The other capacitor is this one. This is the 0.007. Doesn't it look like an electrolytic? It's got an end. It's got a paper cover. It looks like an electrolytic. And does it look like it got replaced? I'm looking at the solder job. Yeah, this has been fooled with. And this has been fooled with. This might be a replacement. What did they do here? Okay, so here's a capacitor here. I can read the value of it. It looks like an electrolytic one based on its style, but it says 0.1. So a 0.1 would typically, non-electrolytic would typically be this size or even bigger than this. This is a little small for a 0.1. Unless it's electrolytic. No, it's marking. It has what looks like an outside foil marking, this band on the end here. That would suggest it's not electrolytic, and it's just a style. It looks like an electrolytic capacitor, but it's not. Let me get out the fried one here. The fried up one. Yeah, it's still warm. I had to dig it out of the garbage. It's still warm. Volts. There's the capacity right there. You're not going to be able to read this. Let's put it on the close-up camera. Let's see if we can read it. So that word right there is foil. Outside foil. Well, I don't think it can be an electrolytic if it has an outside foil. It's a Viking. Well, working. Okay, let's scrape away a little bit here. I happen to have my Swedish fish knife quite handy right here. How do I know it's Swedish? Mora, Sweden. Yes, I'm using the wrong side of the knife. Well, where's the number? Down here? There it is, 0.25. There it is, 0.25. How can you tell if this is electrolytic or not? Well, look at both ends. They look the same. Oh, they don't. Oh, look at this. What's happening? Oh, well, because this thing was overheating. It's blowing out its end seal here. Okay, so that ends the mystery. These are not electrolytic. The whole time I've been wondering, what are all these electrolytic capacitors doing in this radio? But no, they aren't. How do you actually prove it? Well, if it was electrolytic, it would probably say on it somewhere, but good grief. Can you read this? Continental condenser. Yeah, I think I beat this to death. Wait a minute now, if this is an ordinary capacitor, and it was frying, and it was, that's hard to explain. That's hard to explain. And say it again. That is hard to explain. You'd imagine this would have a lot of moisture in it if it's going to conduct electricity the way it was and turn into a heater. And what else can be happening in it? It has to have picked up moisture. And you have that much in it to fry? Well, it is what it is. I have a little bit of trouble believing it. Maybe it's the case that these fancy looking super capacitors are actually pretty junky in the end. So what's going on with this one is probably going on with every other one in here. It's just this guy had 235 volts pushing on him. These other guys probably don't. But they're all probably doing the same thing. So what happens if you put this on a tester? It's not electrolytic, so you know what? I can compare it to my other test results, but I think we can guess what's going to happen here. It's not even worth doing. It's not even worth doing. Let's do this instead. Let's read the resistance of this guy. I'll use this meter here. Now, I've done this before with other bad capacitors, never really got any kind of resistance reading. The resistance is always way too high to actually read on a meter. Let's find out. And of course, we're doing this test with DC. There are, if it is a electrolytic moisture path in here, I'm not saying it's an electrolytic capacitor, but if that's what's going on, then putting a DC voltage will cause a polarization to take place in the capacitor, and so we might see a low resistance at first, and then it may go up. Can you hold this on there? Everything's greasy here. There we go. Well, that says it's 300,000 ohms. That's not very good. 300,000 ohms. If we try a different scale, maybe something different will happen. Now we get a different reading. $60. Okay. Yeah, so these readings don't mean much. More than 60K. Well, it should be sky high, of course. It should be off the scale here, the resistance of a capacitor like that. So that's 300,000 ohms. That doesn't sound like much current would go through it. But, you know, once the thermal runaway, once these things start warming up, they can run away. That's what this one was in the process of doing. It was going to draw more and more current, and where it was going to end up somewhere bad. Smoke. I guess eventually it would drive out the moisture. At that point, it might actually kind of repair itself, maybe, because the moisture would be gone. But that would take a lot. It would take a lot to drive out the moisture. But if it succeeded, probably the next stage would be a complete short circuit through it. I don't know. We're not going to find out because I'm not going to allow that to happen. Well, we found an important capacitor to change. And a 0.25, pretty sure I've got one of those. We're switched off. Let's just pull the plug out. Now, there could be some voltage still sitting here. Just prying off this chunk of wax for no good reason. There's no reason to do that. And this guy, he can live over here now because the wax is kind of solidified, so he can live with all his. Where's the other dead soldiers I had here? Well, there aren't that many yet. It's just this little pile here. Little pile of big guys. Okay, so 0.25, but clearly we're going to have to do the rest of them here. I wonder if we can detect, you know, maybe the next thing we'll consider these. We'll look at these and figure out what's going on with these ones. After I put a new 0.25 regular capacitor in there. Okay, another mystery solved, sort of. Okay, got a nice new orange capacitor in there. Good show, good show. So glad I caught that. Now, right, threaten it with a knife. We want to check out these guys down here, which they do not seem original to me. So what I can see is they are soldered right down to the chassis with quite a monstrous soldering job down there. Two of them coming out. They look identical, one going one way and the other going to the on-off switch. Oh, you know what these are? These are probably across the line capacitors there. Let's get the close-up camera going. We can read the value. I can kind of see it already. Let's see. Oop, oh, no. Clicked the wrong button, Jim. This one here. I thought I could see the value. 0.02. So we've got two 0.02 capacitors twisted together. They're just both grounded. That really doesn't matter that they're twisted together. One lead goes to the kind of a schmozzle on the back of the on-off switch. Wow, that's quite a it's just a lot of dirt on it, a lot of junk on it. And the other one makes a connection to a wire that I'm going to guess. Where's it going? Let's not guess. So there's the transformer hole way in behind there. Get a little more light. It's the hole that the transformer wires come down through. At least one of them. One wire comes out this way, through the tape, and onto the red wire which goes to this capacitor. That's kind of odd. Is there not? Does that wire for sure go up there? I'm wiggling it. Well, it's pretty clear. It's that wire. It's a wire going up. Is it definitely going up in the hole? Where is this it coming by here? Okay, let me use my own eyeballs instead of looking in the camera. Capacitors are really in the way. There, now we get a much better look. So here's the deal with these situations. See the wire coming out on the top there? And I'm sorry it's a little out of focus. You see the insulation is frayed? That's from somebody moving this wire around, probably making that connection that we are talking about. And they moved it around, they've cracked the rubber insulation underneath the cloth, and the cloth itself is giving out. Shine the light on it. The cloth itself is giving out. Well, one by itself is okay. It's not right at the chassis, but if it had happened right at the chassis hole, you're in big trouble. And if you move a bunch of these and they all crack, and they might crack up inside the hole there, you can't even see it. And you develop a short circuit here, it's practically game over for the radio. So you can't be moving these guys around. Look, there's another one, the taped connection. And that's quite common, because the transformer is delivered with its lead wires hanging out. And they mount the transformer, they shove the wires through this hole, and then they move the wires and hopefully solder them into where they're supposed to go. But sometimes this is what they end up doing. They don't solder them to something. This could even be a replacement transformer. Could be. Not likely. Very unlikely. But it could be. So, this is a precarious situation. This is how you can ruin one of these radios without knowing it, just by grabbing these wires and wiggling them around too much. And that's what we're dealing with out here. And one capacitor has gone flat where the incoming power wire is. Is it that taut? No, it's not. What if I wiggle the... There you are right there. What's it ringing? Is it 9? It's coffee break time here. Here's a couple more capacitors. A .02 is not electrolytic, but they have that look to them again of being electrolytic. Okay, that beeping will stop in just a moment. It's pretty close to my microphone, so you're probably getting a blast of the beeping. Okay, let's look on the schematic and we'll find these capacitors. These are almost certainly replacement capacitors here. And they're right on the power line, so let's take a look. Yeah, we'll start with this diagram. And we're looking for the, we're over... Look at this. There's two holes feeding wires in and out of this transformer. So there's probably a primary side set of wires and then a secondary side set of wires. So here's the power cord coming in with a knot. They actually showed the knot. And the cord comes over. And they actually showed this connection right here. Look at that. Right out of the factory, airborne connection to a wire. So why wouldn't they put a terminal here? Save a penny. Where's these capacitors? Where are they located? So they have to be, and see this wire is coming out of the switch and going straight into the transformer primary. This one also, straight into the transformer primary. There's nothing here. There's no capacitors here. So normally these radios have either a capacitor right across the power line, maybe on the other side of the switch, right across the power line, or they have what this one has. They have two capacitors heading to ground. But they're not here on the schematic. Well, not here on this diagram. Let's look at the schematic. Maybe there's something going on here. So here again is the power cord coming in. And we have a straight to the winding and a switch, no capacitors. So those capacitors have been added in. And I could cut them out. You know what? Something's not adding up here. Okay, I see what's not adding up. I see what's not adding up. Let's go back and look at the radio. Okay, it is adding up. So I have this one capacitor coming off and tied, just taped to a wire. But what I didn't see was the other wire that's in that tape bundle, because it's hidden from view, is the other part of the power cord. So this lower part of the power cord, it disappears from view, but it actually goes in. There you can see a bit of the brown there. It goes into this joint here. So that would make both these capacitors, each one is on one leg of the power coming in, and then they're both going to ground. And which side of the switch are they on? Well, so we can see the incoming wire going to the back terminal of the switch, and the front terminal has the capacitor on it. So the last radio I did had capacitors like this properly installed in it, like on the schematic and everything. And these were ahead of the switch. So if you plugged in the radio, the capacitors were energized all the time. Not particularly a bad thing until the capacitors get really old, and then they decide to fry, and they have the entirety of the Ontario Power Generation System available to pump current through them. That's 3 nuclear stations, Niagara Falls. There's even a hydro dam not far from Orillia, where I live. All of them pushing. Well, the issue here is what to do. Leave them, cut them out, or replace them. Those are my options. Somebody put these in here because of a reason. I would say there's effort and time to do this. You had to break into this splice here, and probably messed up the wire down there when you did it, or this power cord. Power cord's not original, so that too would have potentially messed up that connection back there, way back there. Almost impossible to see. Okay, that's the decision point. What to do? Replace? Remove? Just leave them. Coffee. That's right, the coffee alarm went off. Okay, a little bit of coffee has cleared my head. I think the best thing I can do is remove them for now. Return the radio to the way it was designed. There are no capacitors in the original design. And get these out of here. Considering what happened to that other one that started frying up yonder, these ones are hooked right up to the AC line when the radio is switched on. Removing them should have no effect on the operation of the radio. Later, we might conclude they should be put in. I don't know exactly what would prompt that. It would require some kind of prompting in my mind. Something would have to be improved. Sometimes these type of capacitors are really giving the radio a chance to utilize the power system as a ground. Is that part of what's going on here? I don't know, but I think the best thing I can do is remove them for fear of their own failure right on the power line being unnecessarily dramatic. So I'm going to remove them. We will test them too. I'm going to leave a bit of wire here. Nip them right off the bottom. Motorola. Industrial. You have that look of a electrolytic, but they can't be. Not at this size. 0.02. Let's put them on the tester and see what happens. Maybe they're going to test just like new. Okay, so time to gamble. Put your money down. What do you think is going to happen? We're going to have these are going to test terrible. These are going to test typical. These are going to test like new. It's a 400 volt capacitor. Okay, so we're going to hit it with 50 volts. We're watching the eye here. 50. And they're not opening. Bad. This would be bad. Now, having a leaky capacitor here is like putting a big resistor between the power line and the chassis. That doesn't sound like a good idea at all. That sounds like something that could generate a hum. as opposed to help fight one. Here we go. What about you? You're just like your brother. Useless. You're useless. Yeah, good thing I cut these out. At the very least, we should put new ones in, and then I have special capacitors that are designed for this particular service that won't blow up. They're designed so in a failure they don't fail. Yeah, something like that. They don't fail with the thrill of smoke and flames. I think that would be the case. Okay, so this is some odd stuff that's happened here. Now I have a bit of an open wire hanging here. I'll throw a little cap on it or something, but I may have to hook a capacitor back up to this. Is it worth operating the radio at this point? It really isn't. I really haven't done anything here that is going to throw the radio off. Well, what about this guy? And what time is it? It's 10 o'clock in the morning. Look, there's another big one up here. Big guy here. Big one down here. Are they exactly the same make? They look very similar. I'm not so sure they are. This is a sealed tight. And this one up here is an Aerocon. I never heard of Aerocon, but I certainly heard of sealed tight. So, almost certainly I'll be replacing this. Look, there's one down here, another electrolytic pretender. Here, 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 here. One inside here, one sitting here. They're all going to be just as bad as the ones I've done so far. So what I'm going to do is I'm going to see how long this video is. If it's close to an hour, I'm going to end my video. If not, we'll go after this next capacitor. Let me see how long this is already. Okay, well I think I've done enough for today. Tomorrow we'll start off with operating the radio to check its performance. And then I'll go after this guy and probably this big one up here. Big capacitors, big job. Big problems. Not necessarily true, but you can think of it that way. And then we're just from there, it's just a matter of just marching through all the rest of these old capacitors one at a time, or maybe even two at a time, and clean up the radio. Its performance should be improving every step of the way, a little bit. Well, thanks a lot for watching today. Like I mentioned before, it's another beautiful sunny day. I shouldn't be in here. I should be outside anyway. So thanks for watching, and tomorrow we'll do a little more on the radio. See ya.